In a daring announcement, scientists claim to have discovered a new planet unlike anything ever known. This discovery has captured the attention of the scientific community and space enthusiasts alike. NASA, renowned for its groundbreaking contributions to space exploration and its ability to unlock the mysteries of the cosmos, has made a remarkable revelation about this new planet. What makes this planet particularly fascinating is not just its immense size or its unexpected location within the universe, but also the fact that it appears to emit artificial light. The presence of this light is highly unusual and suggests that something extraordinary may be happening on this distant world. Are we standing on the brink of an epical moment in human history, where we may uncover secrets that challenge everything we know about space and life beyond Earth? Could this discovery be a sign that life exists on planets far beyond our own? As we delve into NASA's incredible findings and further explore this mysterious planet, we may be on the verge of answering one of humanity's greatest questions about the universe. In 2007, NASA undertook a monumental mission by launching the Dawn spacecraft, designed to explore some of the most captivating objects in our solar system. This spacecraft was no ordinary piece of technology. It was equipped with 3 cutting-edge ion engines, which allowed it to embark on an ambitious journey that would span many years. The mission began with a 14-month-long study of Vesta, the second-largest asteroid in the asteroid belt. The data and images sent back by Dawn during its mission at Vesta revealed the asteroid's rich and complex surface, offering unprecedented insights into its geological history. Vesta, which had once been a distant, enigmatic body, was now brought into sharp focus thanks to the high-resolution images captured by Dawn. However, this was only the beginning. After successfully completing its mission at Vesta, Dawn was set to embark on the second, and perhaps most exciting part of its journey, a detailed exploration of the dwarf planet Ceres. This phase of the mission was made possible by the unique capabilities of Dawn's ion engines, which allowed the spacecraft to escape Vesta's orbit and head toward Ceres, something traditional chemical propulsion could never achieve. These engines provided a steady and gentle thrust, enabling Dawn to travel vast distances and enter a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt that lies between Mars and Jupiter. For many years, Ceres held the distinction of being classified as the smallest dwarf planet in our solar system. However, this changed in 2006 when Ceres was reclassified following new understandings about the nature of planetary bodies. With a diameter of approximately 950 kilometers, Ceres is not only the largest but also the most massive body in the asteroid belt. This immense size and mass make it a significant object of study, but what has captivated scientists the most are its unique characteristics, which set it apart from other objects in the region. As Dawn approached Ceres, scientists eagerly awaited the first detailed images of this mysterious world, hoping to unlock its secrets. When the images finally arrived, they revealed a surface dotted with bright spots, particularly in a large crater known as a crater. These spots immediately piqued the interest of researchers, sparking a flurry of speculation. Prior to Dawn's mission, our best images of Ceres came from the Hubble Space Telescope, but they were low-resolution and blurry, leaving much of Ceres' nature unknown. Now, for the first time, we had a close-up view, and the potential for groundbreaking discoveries seemed limitless. One of the primary goals of the Dawn mission was to enhance our understanding of how the solar system formed, particularly the role water played in the creation of planetary bodies. The bright spots on Ceres, which had also been observed on other asteroids, offered tantalizing clues. These spots were thought to be composed of highly reflective material, possibly salts that had been left behind after water sublimated, meaning it transitioned directly from a solid state to a gas, bypassing the liquid phase. The possibility that cryovolcanism, a type of volcanic activity involving water or brine instead of molten rock, might be occurring on Ceres added to the intrigue. But the question remained: what exactly were these mysterious lights, and what could they reveal about Ceres? Were they a sign of ongoing geological processes, or was there something even more extraordinary at play? The investigation of these bright spots would soon prove to be one of the most compelling aspects of the Dawn mission, offering new insights into this enigmatic dwarf planet. Ceres is a celestial body that stands out in many ways. Unlike the majority of rocky asteroids found in the asteroid belt, Ceres has a composition more similar to a comet, which suggests it may hold valuable secrets about the early days of the solar system. As Dawn traveled through space for 2 years, it finally began its approach to Ceres in early 2015. This marked a significant moment for both NASA and the scientific community, as it was the first time we would get a close-up look at the largest object in the asteroid belt. The initial images of Ceres revealed a surface covered in craters, each one telling a story of the dwarf planet's long history of impacts. However, the most intriguing discovery was the presence of mysterious bright spots scattered across the dark, rocky terrain. As Dawn sent back increasingly detailed images, scientists began to formulate theories about what these spots could be. Were they simply patches of ice reflecting sunlight, or was something more exotic happening on Ceres' surface? Some speculated that the bright spots might be mineral deposits, while others suggested they could be a sign of cryovolcanic activity, volcanoes that erupt water instead of lava. But the biggest surprise came when closer inspection revealed that the brightest spot was not a single entity, but a cluster of several distinct spots, raising even more questions. The most widely accepted theory was that these bright spots were deposits of salt left behind by the sublimation of water. This meant that Ceres might still be experiencing some form of geological activity, which would bring water or brine to the surface. Once on the surface, the water would quickly evaporate, leaving behind bright, reflective residues. These discoveries fundamentally challenged our previous understanding of Ceres, painting a picture of a more dynamic and complex world than scientists had ever imagined. The potential existence of groundwater or brine beneath the surface of Ceres also had profound implications for our understanding of the solar system and the possibility of life on other celestial bodies. If Ceres still had pockets of water, it could suggest that life, in some form, might exist in places we had never before considered. Ceres is often described as an icy world with a rocky but porous surface, which makes it stand out from other objects in the asteroid belt. Most asteroids are composed primarily of rocks and metals, but Ceres has a more unique composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, giving it a lower density than its rocky neighbors. This suggests that Ceres contains a significant amount of water, which could have important implications for understanding its geological history. The surface layer of Ceres is rocky but porous, with ice and other volatile materials trapped within it. In many ways, Ceres is more like a comet than an asteroid, and its composition hints at a complex history. Beneath its surface, scientists believe that Ceres has a distinct internal structure, likely composed of a mantle made of mud and brine, surrounding a core rich in water ice. This internal makeup accounts for approximately 50% of Ceres' total volume, a remarkable fact that sets it apart from its asteroid neighbors. The presence of this large amount of water ice suggests that Ceres may have once hosted liquid water, especially if its core was heated by radioactive decay early in its history. This potential for water raises intriguing questions about the possibility of past or present life on Ceres, as water is a key ingredient for life as we know it. Further evidence of Ceres' unique characteristics came with the discovery of ammonia clays on its surface. These clays suggest that Ceres may have formed in a colder region of the solar system and later migrated inward to its current position in the asteroid belt. The presence of ammonia lowers the freezing point of water, which supports the idea that brines, water mixed with salts, might exist on Ceres' surface. These insights into the composition and history of Ceres not only deepen our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Ceres is a window into the early solar system, offering a glimpse of how planets and other celestial bodies formed billions of years ago. Cryovolcanism, or ice volcanism, is a rare and fascinating geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes expel materials like water, ammonia, or methane. These substances exist as liquids or gases in extremely cold environments, such as those found on Ceres. Cryovolcanoes on Ceres function by allowing water, mixed with dissolved salts, to rise to the surface. When this salt water reaches the vacuum of space, it sublimates almost instantly, transforming directly from a solid or liquid into a gas. This process leaves behind bright, reflective deposits of salt, which form the mysterious bright spots that Dawn observed on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in a region called a crater 5. This area has garnered significant attention because of its high reflectivity and the periodic hazes that have been observed by the Dawn spacecraft. These hazes are thought to be caused by water sublimation, indicating that cryovolcanic activity may still be occurring, or may have occurred recently, on Ceres. In addition to a crater 5, Ceres hosts several other bright spots, each with its own unique characteristics. These spots are not confined to a single region but are scattered across the surface of the dwarf planet, suggesting that cryovolcanism might be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging the previously held belief that it was a geologically inactive world. As the Dawn spacecraft continued to send back detailed images of Ceres, a wide variety of surface features began to emerge, painting a more complete picture of this intriguing world. Ceres' surface is pockmarked with craters, each one a testament to the long history of impacts that have shaped the dwarf planet over billions of years. Some craters are small and shallow, while others are deep and massive, with distinct ridges and central peaks. These craters tell the story of Ceres' violent past, as it was bombarded by asteroids and other celestial bodies during the early days of the solar system. However, the presence of cryovolcanism and bright spots suggests that Ceres is not just a static, lifeless world, but one that may still be evolving and changing. The discoveries made by Dawn have opened up new possibilities for what we might find on other dwarf planets and icy bodies throughout the solar system. As we continue to study Ceres and gather more data, we may unlock even more secrets about this mysterious world and its place in the cosmos.